Okay, what I want to start with today is just making sure you know how to go between power form and root form. So, for example, if I have x to the power of a half, that can be written as the square root of x. If I have x to the power of a third, I can write that as the cube root of x, and so on. So I just want to quickly see, can you write what is x to the power of a seventh going to be the same as? And I want you to just write that down on your book. How would you translate x to the power of 1/7 from power form or exponential form to root form? And just write it down, just a nice, easy warm-up question. Okay, so I think most of us would have realized that x to the power of a seventh is the same as the seventh root of x. To give you an example of how this might work with numbers, if I say to you, what is 8 to the power of a third? If you type that into your calculators, you will see you get 2, which is a bit weird. Like, how did I get 2? And the reason I got 2 is that 8 to the power of a third is the same as the cube root of 8. And what is the cube root of 8? The cube root of 8 is going to be 2. Now, another way to see this is to realize that 8 is actually the same as 2 to the power of 3. And so you can also see this answer by seeing that these can cancel, and so you get 2 to the 1. So all this is showing you is that powers and roots can kind of be blended together, and it's important that you understand how to do that conversion. Give me a thumbs up if you feel like what I just said now makes sense to you. Give me a thumbs down if you still feel a bit confused. And be honest, I mean, we're online, you're essentially anonymous for the most part. Don't be, be honest. It's better for everyone if we're just honest, because then I can do more things if I need to. Okay. Now, what can sometimes happen is that we need to deal with powers that are not the form 1 over something. So like all the examples I've chosen so far, you'll notice that they're 1 over something. Now, it's very easy to change from this form when there's a 1 there. And in the previous lesson, I gave you the following law, which said x to the power of 1 over n is the same as this. So if you need to write that down, you can do it. That's a straight conversion. The power of 1 over n is the same as the nth, the way we say it is the nth root of x. Okay. Now, that's great for when we have fractions of that form. But what happens when we have something like this? X to the power of 2/3. We no longer have a number with the 1 as the numerator. So in this case, numerator is 2, the denominator is 3. Now, the way we write this in terms of a root form or radical form is we write it as like that. And I want you to focus on the really important part. It's the denominator, which is the part that goes outside. So just like before, the n at the bottom here, and the n here is on the outside. The numerator stays inside, the denominator goes outside the root bracket. Now, what I want you to do is I want you to write x to the power of 4 over 5 in the root form, in this type of form for me. So do that. And I also want you to write x to the power of 6/7. That would be awesome. Off we go. And if there are questions, please raise your hand or pop it in the chat. I'm going to get some water while you... So like we said before, the important bit is, well, not the important bit, but the bit that goes outside is that. And so you should get that that is the same as that. And for this one, we should get that that is the same as that. Okay. So if I take this idea, just again, give me a thumbs up if you're comfortable. Give me a thumbs down if you're feeling a bit unsure. For now, all we're doing is we're playing with the notation.
Mr. S?
Yeah.
Can you please explain an example again?
Yeah. But the one currently doing with the fractions, with the 2/3 and stuff like that.
Yes, there's some confusion in the chat.
Okay. If we look at what we did when we started where we had something to the power of a fraction where the fraction was always 1. So notice how there was always a 1 in the numerator and an n was the thing at the bottom. So that was the law. Now, the second part of today's lesson is dealing with the time when the way the law, let me actually write the law out for you, and then I'll do some more examples. So if we said instead of it's 1/n, we say it's m/n. And then we write it as, we write it like this. And what this is dealing with, it's dealing with the situation where it's no longer a 1 as the numerator. So just to kind of, if you think of a fraction, the top one is called the numerator, the bottom one is called the denominator. And so in the second part of the lesson now, we're dealing with situations where the numerator is no longer just 1. Okay, so let's see another example. Let's say I have, let's move this out of the way. Let's say I have 8 to the power of 2/3. If I have 8 to the power of 2/3, that is the same as the cube root of 8 squared. Now, what do you think the answer to that is going to be in the chat? Maybe pop it in the chat. What's the 8 to the power of 2/3, or in root form, the cube root or the third root of 8 squared? What's the answer to that going to be? Now, if you use your calculator, you can get it quite easily, but you can also do this without your calculator. So, you know, in terms of, there's a couple of ways, but I suppose you could say this is the cube root of 64, which is just going to be 4. So that's the one way to get the answer. And I think most people are happy with that. But just to show you how, you know, well, you could get it in the other way too, by breaking the 8 down if you wanted to. I'm not going to do that now because it probably will take too long. But ultimately, I want you guys to be comfortable going between power and root form. Let me do one more example like this before I move on. What is 16 to the power of 3/4? And I don't want you to use your calculator here. You have to use your brain power. and it'll help you to convert it between the different forms. So what is 16 to the power of 3/4? Off we go, ladies and gentlemen. Maybe somebody could come online and tell me. That would be even better. Who wants to volunteer as tribute? I don't mean it's not that bad. But,
oh, we haven't Tebogang volunteering.
okay, let's go to you, Tebogang.
Hi,
What do you
Sam.
think we need to do? Hey.
I first took the 16th and put it in its prime factors, which is 2 to the power 4. And then I multiplied the exponents 4 times 3/4, which gave me 12/4.
So you get, so you get 2 to the power of 12/4, which is 2 to the 3, which is 8. Yeah. And if we were writing it, we don't have to write it in root form, but if we were writing it in root form, it would just be that. Just so we're comfortable switching between the two. Okay, so I hope that that's making it a little bit easier. It's just about being comfortable converting between the different forms. All right, let's move on. So what we're going to do now is I'm going to look at solving equations. Okay, so solving equations that have rational powers. So this is something slightly different. And I want to point out, well, I want you to ask you, if you solve an equation, you normally end up with x by itself and an answer on the other side, whatever that may be. But that power is 1 normally. Now, when you have to solve an equation like this where the base is a variable and you've got rational exponents or exponents that are fractions, what can you do to get x by itself on the one side with a power of 1? Who thinks they know the answer to this? Okay, let's go to Blessing. Blessing, what do you think we do? Blessing, what do you think? Can you hear me? Okay. So you don't divide by 2, because divide by 2 would be if you have like a 2 in front here. The thing that's causing you headaches is the x to the power of a half. You could square root it, but that's still also not good. You're right. This question is saying, what is the square root of x equals 3? That is the type of question. But I was thinking, can't we do this? Can't we raise both sides to the power of 2/1? If we raise both sides to the power of 2/1, or raise both sides to the reciprocal, what do we get when these two powers multiply? Well, we're going to get 1. So we get x to the 1. And then what is 3 squared? It's just going to be 9. So the process that we followed is we've just raised both sides of this equation to the reciprocal power of what we started. The fancy reciprocal is such a fancy word. We could say that we've raised it by the opposite way around. We just flip it upside down, basically. So that's what we do when we're solving equations with rational exponents. There's a little bit of a checklist here, but essentially that's all we do. So let's see if I give you another one. Can you do it? I want you to solve this equation for me. And I don't want you to use your calculator this time. So no calculator. And I want you to take the method that I just showed you and think, what is your first step? And anybody who can give us a hint in the chat, you get a virtual gold star. So please do share your thinking.
Don't be shy, guys. Promise we're nice.
Very nice. So
We have a
popular.
hand up thing, Mr. Ist.
Okay, let's go to Blessing. Lacing, what do you think?
Multiply both sides by exponent.
Okay, so
Four
I
over
heard most of it. Okay, so again, it's not, you're absolutely right, 4 over 3 is important, but we don't multiply, because multiplying by 4 over 3 would be like putting it here. I know it sounds a bit weird, but we raise it to the power of 4 over 3 on both sides. So we're basically raising it to the power of 4 over 3 on both sides. And when we do that, this cancels this cancels this, and we get x is 8 to the power of 4 over 3. But we're not allowed to use a calculator, so how do we get the answer? That's the question. Who wants to help me getting to the answer here? Fila, what about you? You got an answer? How did you get it? Are you willing to share? Okay. Fila, let's go to you.
So I said x to the power of 3 over 4 raised to
Okay.
the power of 4 over 3 is equals to 8 to the power of 4 over 3. And then I'm just going to go where you left the answer. So I changed 8 to its prime factor, prime base, and to the power of 3. So I said 2 to the power of 3 is raised to the power of 4 over 3. And then I cancelled the what do you call it? The powers, which is 3 and 3, and I was left with 4. And I said 2 to the power of 4 is equals to 16. Therefore, x is equals to 16.
Winning. Well done. Perfect. So that was really good. Well done. So what you see here is you can think of 3 as 3 over 1 if you like, if it helps you, and the 3's cancel, and you get 2 to the power of 4 is 16. Okay, so what we're trying to do in this case is we're just trying to get the answer. So if you, in your calculators, let's just check if this is working. See what you get if you put 16 to the power of 3/4 and check that you do get 8. If you get 8, give me a thumbs up in the chat. So for Tejo, see if you get, so we're solving for an answer for this equation, but it's a bit of a different type of equation in that it's got powers here. Rational exponents. Okay. Let's do one more like this, just to make sure that we know what's going on. Okay. How about you do this one? So solve that equation for me, noting that the x that we normally have to solve for is here, but there's something a little bit different in front. Maybe some people can help us by putting in the chat what they think might be a good first step to solve this equation.
Mr. Ace,
Mm.
I think we have a question from Debogeng.
Okay, let's go there. Go ahead, Debogeng.
Oh no, sir, I wanted to answer a question, but it was already answered.
Okay, well, while I've got you, what do you think we do with the 3? Or how do you approach this question?
I divided both sides by 3. So it's x to the power 1 over 3 is equals to 4.
Okay, and then your next step?
Oh, my mind just goes. Okay, multiply both, multiply the exponents by, I get it's 1 over 3. So you say times 3 over 1, and then the same on the other side.
So you raise both sides to 3 over 1. Okay, and then
x to the power 1 is equals to 2 to the power of 2 times 3 over 1.
Okay, so then, well, so these are going to cancel. So you get x to the 1, and then what's on the right-hand side?
It's 4 to the power 3 over 1. So it's 2 to the power 2 times 3 over 1.
Yeah, or you could just say 4 times 4 times 4. All works, and we get 64. Okay, you guys have done really, really well so far in solving these equations with rational exponents. I want to point something out. I've been a bit sneaky. All of the questions so far, if you look at the power, notice how the numerator is a 1 or an odd number. Now, if the numerator is an odd number, there's always going to be one solution. However, if the numerator is even, there's going to be two solutions. It's a little bit like, do you know if you have the square root of 9, you have the answer plus or minus 3 as the answer to the square root of 9 because 2 is even. But if I say to you, what is the cube root of 27? The cube root of 27 is just 3 by itself. So I think you would have learned this in grade 8 and 9, that if you have an even root, you have two answers. Whereas if you have an odd root, you have one answer. Give me a thumbs up if you've heard that before. Give me a thumbs down if you're like, what are you talking about, crazy man? Okay, so let me show this to you in other ways. Like if I say to you, what is the... So even if you're just learning this for the first time, if I say to you, what is the square root of 4? The square root of 4 is plus or minus 2, because minus 2 times minus 2 gives you 4, and 2 times 2 gives you 4. But if I say to you, what is the cube root of 8? Well, cube root of 8 cannot be minus 2. It's only going to be plus 2, because 2 times 2 times 2 is 8, but minus 2 times minus 2 is plus 4, plus 4 times minus 2 is minus 8. So I'm just trying to show you that it matters whether or not the root is even or odd type of thing. Now, let's go to a question where I can bring this out. So if you look at this question here, you will notice that it says that the numerator is 2. It's an even number. Now, when you have an equation of this form where the numerator is even, you are going to have two answers the same way that if the root form is like even, it would have two answers. So how do we actually do this? It starts off a lot like what we've been doing so far. So I would like someone to tell me, if you were solving this like we have been doing since the beginning of this lesson, what would your first step be? You can come online or you can put it in the chat. What would your first step be if I had never said what I said to you about two answers? What's the logical first step?
Anybody?
Okay, Fila, let's go to you.
You must raise the powers into its reciprocals.
So would you be okay with 3 over 2?
Yes.
Okay, perfect. Absolutely perfect. So here's the one change we do. We know that these are going to cancel, so life is good. But on this side, we say plus or minus 4 to the power of 3 over 2. Well done, Fila. That was fantastic. So the only little difference we do is that we add a plus minus if there was an even numerator. And the reason we add a plus minus is also kind of clear in that if we raise something to 3 over 2, this 2 is kind of like the same square root. That's why you don't need to know that, but you know, that's where this 2 over here is like a square root. So it's like a plus or minus. Okay, so then how do we get to final answer? Well, I think we can break the 4 into 2 squared. So that's all good. Notice how the plus and minus is just hanging out in front, not bothering anyone. All good. And now this can be 2 over 1, so that's going to cancel. And so my final answer is plus or minus 8. Now, I know we need to practice this more, but just to make sure I'm not telling you lies, I want you to put into your calculator, what is 8 to the power of 2/3? And I also want you to put into your calculator, what is minus 8 to the power of 2/3? I'm going to explain again, don't worry. But let's just check here. Am I telling you the truth, ladies and gentlemen? Is 8 to the power of 2/3 equal to 4? Is minus 8 to the power of 2/3 equal to 4? Okay, I'm telling you the truth. This is good news for all of us. Okay, so the main thing I wanted to show you to watch out for is the numerator is in the original fraction is even. We'll have two answers, and we just add this plus minus in when we raise both sides to a power. I'm telling the truth. I try to tell the truth as much as I can. Now, we're going to do another example now, but I just want to give a chance for you to take a screenshot before I do this next example. Okay. Awesome. Okay, so let's say I'm looking for one which has a no, it's not. Okay, let's do this one. Let's bring this out, and then let me see if I can make that stuff disappear. Okay, so we are going to focus. We're going to have a break right now because I'm working you guys hard today. We are going to try and solve this equation. But before it can be the equation I want it to be, I need someone to help me translate this from radical form or root form into exponential form. Who could tell me what this is written as exponential forms? Could we convert this from radical to root? Yeah, Kanya, let's go to you. What do you
Hi,
think?
sir.
Hey.
I think we are going to say x to the power 4/5.
Perfect. Loving it. So good. Okay, now, while I've got you, are you still here, Kanya?
Yes, sir.
Do you notice, Kanya, that there is a 4 in the numerator?
Yes.
How many answers is this equation going to have?
What do you mean, sir?
Like, is there going to be one answer, or is there going to be two answers to this equation?
I don't know. I'm not sure.
Okay, no problem. So thank you, Kanya. You've been very helpful. So what I want to point out is in this question, the numerator of the fraction is an even number. And when the numerator is even in this type of question, there's going to be two answers. I want you guys and girls to try and find me what those two answers are. So over to you. There are going to be two answers. See if you can use the method that I was showing you above here. Oh. So you've got x to the 4/5 is 256. I want to know what are the two answers to this question. And then we're going to have a well-deserved break. I'll let you use your calculators on this one. So for Techel, what we're doing is we're raising both sides by the reciprocal of the power that's there. So it was 4/5. So both sides are now being raised to the power of 5/4. So then I get x to the 1. But now because there was an even numerator, we are going to add the plus minus here And then we get left with this. And because I'm allowing you to use your calculator, you should be able to get an answer for me straight from there. What are you getting? The answer is indeed plus or minus 1024. Yeah, and you can check that answer by putting it back in the equation, but we don't need to for now. So look at that. You've already done an equation that was in root form. You changed it, and you recognize there were two answers for when the numerator's power was even.
Mr. Ace,
Yeah.
can you please explain how you got to that answer again? There are some students in the chat who are still confused.
So if I look at this equation, step one was to go from this form into this form. So that's step one, and now I've got this equation. Step two was to see what the fraction was, and it was 4/5. And I'm going to raise both sides to the opposite of that, which is 5/4. When I do that, those two cancel each other out, and I'm left with x to the 1 on the side. Now, because I notice that the equation with a fractional power has an even number at the top, right? Or even number as the numerator, I add the plus or minus at this step. Now, Tando's asked, why is there two answers? Well, Tando, if you think about earlier on when I was talking about square roots, do you remember square roots or even roots have two answers? Now, when you think about this 4 that is being applied on both sides, that's actually the same as taking the fourth root. And the fourth root of something or an even root of something will always have a plus or minus answer. So I was showing this to you earlier on in the lesson. So let me think about how I would show it here. If I say, what is the fourth root of 16? That is the same as 16 to the power of a quarter. Okay. And this is going to give you the answers essentially plus or minus 2. Okay, so I'm not going to go any more detail than that. Is it necessary to write the plus and minus? It's only necessary to write it in the occasion where there are two answers. So when this numerator is even. Look, the worst that will happen is you'll lose 1 mark. It's not the end of the world. I don't want you to be so scared of it that you don't write something down. But there are two answers when the numerator is even. Okay. All right, we've been working for almost 40 minutes now, so it's important we have a break. So what I want you to do, I'm going to come back to these questions after the break, but what I want you to do is I want you to stand up for a second and join me in giving your body a break like this happy jump. So stand up where you are, because you need a bit of time for it to settle. There we go. Connor is showing us the way. Let's do some jumping jacks. I like it. There we go. There we go.
Well, I did miss gym this week, so.
I love it. I love it. I love seeing everyone. Look at that. Okay. After some jumping jacks, I want you to roll your shoulders. Roll them out.
Please put on your cameras, guys. Don't be shy. We're all in this together.
It's a family meeting. Here we go. Okay. Roll your shoulders back. Roll your shoulders forward. Okay. Give your neck a little stretch to the left. Give your neck a little stretch to the right. Oh, that feels good, but maybe my neck is just always sore. Okay, one more stretch. Let's do this one. Do another one. And shake it out. Shake out those hands. Get nice and loose.
Loving this participation.
And like your body, like, I don't know about you guys, but I've had a long day just like you, and it feels amazing when you give your body a bit of time just to unwind and relax.
The brain juice is flowing now.
I always feel like I've got a bit more energy when I've done that.
Oh,
Cool.
Connie gave us a thumbs up, Miss Days.
Oh, fantastic. Connor you've discovered the secret. All right. So here is the logic puzzle for today. What is a cat plus a, I don't know what is that, plus something plus a bird? I want to know what the answer is. I'm pretty sure the first one is 5. Pretty sure this is 15. Let's use a different color. Now be careful because I think it's a raccoon. For me, the raccoon must be bigger than 40. How much bigger than 40? Well, if I add 15 to both sides, the raccoon actually has to be 55. Because otherwise 55 minus 15 is 40. So that is 55. So what is my final answer going to be? Do you agree with my reasoning? I know that the bird is 15. The raccoon is 55. So what is the final answer going to be? Oh, so it's a minus sign. Yes, I think this caught some people. So this is a minus sign. And maybe it was a little bit small. So that caught out a few people. So Kanya, Alwande, Tendai, Fila, Nalissa, Yenzi. Okay, so it's actually so the final answer is 75. And I can see the class has got this. Well done, everyone.
Nice
Everyone
work,
said,
guys.
Now I understand why so many people were saying 45. For those who've been doing this for a while now with us, are these types of questions getting a bit easier now? Do they get easier with time every time you see one? Just curious to know. Yeah, because I do mix them up, but I like to do these every now and again.
Sandy Sile says cheers to us, God 45.
Okay. So what we're going to do next is we are going to move to a different type of equation. So I want you to tell me, here is, instead of an equation with rational exponents, this is called an exponential equation. And I would like someone to tell me what is different with this type of equation compared to the last one. And maybe if you've got any methods or tips. So this is called an exponential equation. Exponential equation because, well, you can tell me, the last one was called an equation with rational exponents. Who would like to share their knowledge of this type of question? Let's go to Paul. And then Jens after that if we have time. Yeah. Paul?
Hi, sir. So what's different with this question is that in the previous question, the x was the base, but then in this question, the x is the exponent. And then, yeah. So how we approach this type of question, we need to write 8 as a factor of its prime base. So it's going to be 2 to the power of 3. And then we're going to equate the exponents, which will mean that x is equal to 3.
Perfect. So you have given us all the knowledge, Paul. That is fantastic. This is an exponential equation because the variable is an exponent. And the technique we use here is not raising powers to both sides, but rather we want to have it so that the bases are the same on both sides. And we then can equate the exponents. So I thought you did a really good job there of explaining that. So let's start with this type of question. get me the answer to this equation. And when you guys are done, you can pop it in the chats.
Keep going, guys. Almost there.
You can do it. Okay. So because the bases are the same to start, we can actually just do this. And then you should get x is 1. And some of you might have been able to do that by inspection. So that's not too hard yet. That's fine. Good to just start with a couple of basic ones. But that's the simple exponential equation. Okay, let's take it up a notch. Two to the power of x equals 0.25. I want to give everyone a chance to think how we can do this. And tips. Oh, okay, Connor, I'll move it down. If you feel like you have some knowledge about this, pop it in the chat. I'm not going to take audio right now, but in the chat, tell us how, if you have a tip that can help us handle the thing that's different. Fetejo, can you see now? Is that okay? Okay, so Felile says that we can convert 0.25 to 1/4. I think that could be quite helpful. Yep. So if we write 2 to the x as 1/4, and then Yenzi has said make the bases the same. Well, I was thinking that I could write 4 as 1/2 squared. But it's still not the same. Who knows what I need to do to get to the answer from here? I just have to move this from here up to here. But then I get that. And then the answer must be -2. We absolutely are. Because ask yourself this, if you type into your calculator 0.25, isn't that is exactly the same as a quarter. But the reason a quarter is so much more useful to us is a quarter can be broken down to eventually a place where the bases are the same. So because we can choose the fraction however we like, but a quarter is really helpful because it's related to 2, and 2 is our base. If I had written this as 2/8, it's not wrong, but it's just not as helpful straight away. So if you move the 2 up, Alyssa, doesn't it become negative? You're absolutely right. It becomes negative, yes. Okay, so you're all doing, I'm going to answer the question, but for those who are feeling comfortable, I want you to have a go at the slightly harder one now. I'll give you more time for this, and then I'm going to answer the questions from this one here. So it says you took 2 squared to the top. Why? Okay, so Tando, what I wanted to do is I wanted to have it in this way that I had 2 to the power of something equals 2 to the power of something. And at the moment, the 2 is at the bottom. So because the 2 is at the bottom, I can't directly compare the bases and drop the bases. It has to go up to the top. But then when I do that, it has to change from 2 to the positive 2 to 2 to the -2. So the aim is to make the bases the same. Yes, that's exactly what Paul was saying earlier on, where he said, with this type of question, it's a different type of equation. And so the method we use is different. Okay, so I hope that helps. Let's keep having a look here. Yeah, no, we don't have to go at rocket speed here. Things are getting harder now. So and one of the things at the end of the lesson, we're going to do a poll. And what we want to see from you guys is kind of how you felt about the general pace of the lesson. And we do try and adjust our pace based on those polling results. Okay.
Mr. Ace, is there time to explain number 1 again for Matsobane?
Yeah, there is time while people are working on number 2. So what makes number 1 difficult is the fact that there's a decimal, right? That's what makes number 1 difficult. Now, if we had a way of changing the decimal into a base 2, our question would be very easy. So we start by writing this as 1/4. Then we still want to get a 2 at the top there. So we write 1/2 squared. We go, we're getting warmer, but we're not there yet, because I still need to bring the 2 up to the top. And if I do that, I get 2 to the x equals 2 to the minus 2. And now we can see what the answer is. Okay, so I hope that helped a little bit. Now, this next one is a little bit all over the place, but I think this previous question helps us, because this 3, I'm thinking if it's hanging out at the bottom, it's not helping anyone. And I'm also thinking, can't this 9 be broken down into base 3 as well? Because the whole type of thing with these questions is you want them to be base 3, because that will allow the question to just work. So that's my tip. I'll give you more time to work on it though. This is getting proper. This is getting to a pretty decent level now.
Mr. Ace, we have a hand from Enhle.
Enclair, let's go to you. What's your question? Hi, Enclair. Can you hear me?
This.
Hey,
Hey,
how's it going?
I'm good.
Good, good. What can we do? What was your question?
Say I'm asking from number 1, how we got from 2 to the power of x equals 2 to the power of minus 2.
Okay.
How we got minus 2 up there?
All right. Can I suggest you have a look? There's going to be a recording of this video. The main thing you need to get is you need to get that a quarter is the same as 0.25. And then once you agree with that, you then need to understand that 4 is the same as 2 squared.
Yes.
And once you understand that, you need to understand that if you bring the 2 squared above the line, it goes from a positive to a negative power. Okay, but have a look at the recording, because it's going to help you by going over it again, I promise.
Okay.
All right, watch this. Watch this part here. Can you see the 1/3 here? If I bring the 1/3, it's now 3 to the 1 at the moment, but if I bring it above the line, it becomes 3 to the minus 1. Now there is already a 3 to the x plus 1. And over here, I'm going to write this as 1/3 squared. However, at the moment, the bases are not the same on both sides, because this 3 squared is 9, but it's hanging out on the bottom. So now I need to bring this to the top. And when I do that, I'm going to get 3 to the minus 2 over here. And on this side, I've still got basically this. Give me a thumbs up if you understand how I got to this point. In the chat, give me a thumbs down if you feel a bit like you've left the bus.
Mr. S,
Hmm.
can you please explain why it's just the exponent that becomes a negative and not the base when you take it to the top?
Okay, so this goes back to lesson 1 in the series when we spoke about the laws of exponents. So if we talk about, if we bring something, how do I say this? So if I say to you 2 to the minus 1, that is the same as 1 over 2 to the 1. So the moment you move things below and above the line, only the powers change, not the bases. Okay, that's what I'm going to say for now, and say, have a look at video or the beginning of video 2. We definitely discuss this further. But let's just, for now, finish off this last question, and then we'll come back to it if there's more time. So this next step says the bases are the same. Okay, the bases are the same. And law 1 from lesson 1 of the series says we can now add the powers. And the 3 to the minus 2 can just stay there. Now, minus 1, let's zoom in so that we can all get like a big picture here. Minus 1 and plus 1 are going to cancel each other out. And so I'm left with 3 to the x is 3 to the minus 2, which means the answer to this whole equation is x is minus 2. Oh, sorry, guys. I must be making you dizzy. So what I want to point out is as we get to harder exponential equations, it seems like the technique we need to get comfortable with is changing it so that all the bases are the same and then moving them around so that we can drop the bases eventually. Okay. Now, the more you do this, the more you practice, the better you get. Obviously, you have to do a couple of examples. And there are different types of exponential equations. So you need to learn how to recognize. But in this type of question, this is one where the bases can all be the same. And so then the process goes from there. Now, we've done quite a lot today. And if we do any more, I think it's going to cause confusion. So we're going to pause and stop there for now. And we're going to continue our journey on Wednesday. But Lebo, could I ask you to share the poll with the students? And please do give us honest feedback about how you found the lesson. And we will do our best to take that feedback and incorporate it into future lessons. Decimelo says, sir, please explain the third set. Do you mean the third? Which one do you mean, Decimelo? Which one do you mean the one that's on the screen right now? Zandisile, you can do, it's actually not as difficult as you can do number 3. It's interesting, but it's not compulsory, but the third step. So, okay, if you look at this question, let's go through it one more time. If you look at the third, the 3 to the 1 goes to the top and it becomes 3 to the minus 1. Okay, so that's this one over here. The 9, which is here, is this one over here. 3 squared. And it, when it goes to the top, becomes 3 to the minus 2. And the next step is to say, okay, well, these 3s are all yellow, or they're 3s. Now I'm just going to add the powers, and I'm left with 3 to the x. And on this side, I'm 3 to the minus 2, which means I can just focus on the fact that x is minus 2. And that's my answer. All right. If any more questions, I'll have a go at them. But I think we've worked hard, and I think we all deserve a bit of a break now. But I really enjoyed teaching you. I hope that the lesson was helpful. And thank you for giving us the feedback. We do really try our best to take the feedback and adopt the lesson, adapt it to, just as best we can to help as many students as possible. Oh, it's a pleasure. Thank you for all the nice comments, guys and girls. It's really nice of you. And maths, maths is really about practice. So getting a good, clear explanation, and then you just need practice. It's a little bit like good technique in like any sports. Someone needs to show you the good technique. I'm working on my backhand at the moment in tennis. I'm a big tennis player. I love tennis. And it's just like, you have to get your technique right. And then it's just practice. Like, you don't just get it from one observation. You have to just build that muscle memory. Cool. So for question 3, it's actually the answer is x is 2. And the reason it's x is 2 is the quarter is the same on both sides, right? The 12 is the same on both sides. And so the answer has to be x is 2. It looks fancy, but it's really actually super easy. Yeah. It's like dressed up. It looks complicated, but it's really, Awesome. I'm glad to hear that, Warren.